In this series, we want to start to learn how to factor some different types of ideas. And one tool that's very useful for us is helpful for us is to determine what the greatest common factor is between a set of terms. So I have three different sets up here. In this first set, I have 6x cubed and 10x squared. Well, to find out what the greatest common factor is, let's look first at the coefficients of 6 and 10. And I want to figure out what number goes into both the 6 and the 10, but it's the greatest number that I can find. And 2 goes into the 6, and 2 goes into the 10, and there's no other number that's higher. So I know that 2 is part of my greatest common factor. I have an x cubed and an x squared. Typically, when you're looking at variables with exponents, you're looking at the exponent that's the less, or that's the smallest. X cubed and an x squared. Well, x squared goes into x squared. X squared also goes into x cubed. So 2x squared is my lowest common denominator, or yeah, my greatest common factor. There's always lowest common denominators, which is a similar term too. Greatest common factor for those first two terms. And this third one, 15y to the 5th, 9y to the 4th, and 27y to the 3rd. What number goes into 15, 9, and 27? The greatest amount in each one? 3. And y to the 5th, y to the 4th, and y to the cubed. I'm going to again look at my variable that has the lowest exponent value, in this case y to the cubed, and that's going to be my variable exponent. So my greatest common factor is 3y cubed. And then lastly, I have x to the 5th, y cubed, x to the 4th, y to the 4th, x cubed, y squared. So let's look at my x's first. X to the 5th, x to the 4th, x cubed. X cubed is my lowest amount. And then y cubed, y to the 4th, y squared. So x cubed, y squared is the greatest common factor for each of these terms. And it doesn't matter that if the term itself is x cubed, y squared, and that entire thing is the factor, that's also appropriate, or that's also fine.